Hi everyone. First of all, welcome to the new ones and welcome back to the old ones. My name is Paras Pundir and I'm the Reactor Program Manager for Microsoft Bangalore Reactor. And Reactor program is an offline community program, and we used to had a space, complete space where we used to host a lot of meetups, and it's been active from last year October, and it's been a fun ride till then. We have been able to host more than 45 events, and probably 20 plus different communities and hackathons were online and what real time ones. So that has been done. And if you see Reactor, so the reactor is coming from outside India. It's there in US, different 4 locations. It's there in Sydney. It's there in Tel Aviv. It's there in China. It's there in UK. It's there in Canada. So it's an it's a Microsoft corporation program, and we are lucky to have it in India, and it just recently started. So this is the series which we have been running under Reactor. It's called Azure Happy Hours, Reactor Happy Hours, and these are like we used to host these mostly on Thursdays and Fridays in the evening, and yeah, like
Oh, we lost you there for a bit.
in last Azure Happy Hour, and the session people actually loved it, and we actually have a whole video series done for that, and we have been sharing it everywhere. So we'll make sure that we share the last talk session link here in the comment section. And today we will also be recording. So just to let you know that we will be recording the whole session, and we will be again sharing it again on our Reactor YouTube page, so where you guys can follow it. And yeah, like that's about it, I guess. I'll not take much long, and I'll give the time to Dave, and probably a good time to for him to start, and probably tell a bit about himself, so that we can kickstart the session. So yes, Dave, off to you.
Okay, thank you very much, Paris. Appreciate that. Hey, everybody. My name's Dave Glover. I'm what's known as a cloud advocate at Microsoft. I'm based in Sydney, Australia, and I've got a focus on the Internet of Things, is kind of where I fit in. So the title of this talk is Technology for a Better Life. And I've come up with a scenario. You might have seen it before, but the idea is kind of shopping for vision impaired people. But the other concept I had in my mind was maybe you're new to a country, you didn't know the language, and you'd be able to hold your camera over a piece of fruit in the supermarket, and you'd be able to it would be able to tell you what that bit of fruit was. Um, so is my sound coming through? Okay. Can someone just put in the comments if my sound is coming okay? Okay, cool. Yep. So I think in general, okay, sounds good. Alrighty. I'll try and keep an idea. Okay, someone said loud and clear, so that's good. Thank you. So also I will try and keep an eye on Q&A as we're going. But obviously that's a little bit challenging just while I'm talking and trying to do some demos and try and keep on the Q&A. So I will do my best. Now you can follow me on Twitter at dglover, and I also put a lot of code up on GitHub, so GitHub/gloveboxes. So do feel free to reach out to me. Yeah, cool. And I was told by my boss, who's from India, that these things called dalgunas are becoming super popular in India. So he said, put one of those on there, and Kingfisher, so I'm a bit of a fan of Kingfisher. So if you're relaxing for the day, hopefully you'll have one of those. But just before I start on my session, I just wanted a bit of a call out to an event that happened here this week. It was a global event, and obviously the shape of that event changed very much because of the pandemic. But do check it out. If you haven't already checked it out, then search the internet for Microsoft Build. It actually was kind of an interesting event because it went for 24 by 7 for 2 days. Oh, sorry, so 24 hours by 2, so 48 hours continuous. So there's a lot of content out there, and you can go up to mybuild.microsoft.com and you can just go and hunt for sessions that you'll be interested in. Now, there was a really cool session that I thoroughly recommend. It's called The Future of Tech with Kevin Scott and guests. And at the moment, the only location I know where it is this twitter.com address. So perhaps grab a screenshot of that, or I'll put it in the chat for that matter. And it was an amazing session. One of the things they talked about was work we're doing with a company called OpenAI. And with them, Microsoft has built out an AI data center. And I think in its own right, it's something like the fifth largest supercomputer in the world, with something like over 285,000 CPU cores and over 10,000 GPU cores. Quite extraordinary. But what I loved about the session, it just kind of outlined really his vision, or the vision for around, really most of it's really centered around AI. So that's kind of top of mind for most of us. So absolutely do check that out. I would say that make that your first port of call. Okay, so this session here is predominantly, in fact, it's pretty all written in Python. Everything's pretty much open source, and you can use these, the services that I use, you can use for free of charge. So you can head up to azure.com, sorry, azure.microsoft.com/free, and you can sign up. So I'm going to use a couple of cognitive services. One's called Custom Vision, and the other one I'm going to be using Speech. And you can use those services for free up to a certain limit. So, for example, on Speech from memory, it's in the order of 3 million characters per month, I think it was. And for the custom vision training, I think you can train models up to about 5,000 images for free. Or if you're not on mute, can you just make sure you're on mute, please? Okay, so just kind of a bit of a solution overview. So what I'm going to be talking about is intelligent edge. And then we're just going to talk about how to integrate that data that's coming from an intelligent edge. In this case, my intelligent edge is actually going to be a Raspberry Pi, but it could also, and quite possibly would be, a mobile phone application. And then I'm going to talk a bit about cloud integration and then how to get that data into storage. And then I'm going to do a bit of data analysis on it, just using Jupyter. The main point of the stuff I'm going to show in Jupyter is some of the tips and tricks for debugging Jupyter notebooks. Now, again, I'm assuming if you've done a lot of Python, and I'm guessing by the number of people registered, and just generally Python's a pretty popular language, then I suspect you've also done a fair amount around Jupyter notebooks. So the first part here is going to be broken up. So the demo is basically broken up to 3 chunks. And the first part is just going to be the intelligent edge. Now, I've just realized I've shared up my desk in the wrong way. So I'm just going to, sorry about this. I'm just going to have to unshare my desktop. Okay, hopefully that's come back again. Right, so hopefully I'm still there. Just double checking the comments. No one said I've disappeared, so that's always a good thing. So the first part of this demo, um, it is literally running on a Raspberry Pi. Now, I must admit, the demo that I've recorded is actually running on a Raspberry Pi version 4. And this, as you can see, is not a version 4 if you know your Raspberry Pis. I think it's probably a version 3B or something along those lines. But it actually was more than capable of running the machine learning models that I exported out from Azure Custom Vision. So you can see I've got a setup here. It was pretty makeshift. The idea was I just wanted something to hold a camera up above the fruit. As you can see, the camera's plugged into the Raspberry Pi, and I had a speaker hooked up to that Raspberry Pi, and it was running these machine learning models and calling upon the speech services inside Azure to say, hey, look, you've scanned an apple and things like that. So that was kind of how it does. Now, so the next part, I'm hoping the sound will come through, and I'm going to keep an eye in the comments. If the sound doesn't come through, can you please make a comment in the comments, and I will try and fix it. So I've just got a video. So this is kind of the demo in action.
Starting scanner. You scanned a red apple. You scanned a banana. You scanned a green apple.
Okay, cool. So that was the kind of the demo. So you can kind of see, as I mentioned, the whole
You
thing
s-
is running on a Raspberry Pi, and it was surprisingly good. You could probably do um, an image a second, kind of in that kind of order. I did a few tricks. So I did a bit of optimization in there as well. So the code is all available on my GitHub, and there's a link to the code at the end of the session. And I did a few bit of Python optimization, which you can find on my GitHub, but it worked surprisingly well. Really was
starting s-
quite fun. So in terms of how this demo worked, so the first thing I did is I used custom vision to go and build a machine learning model. And uh, the beauty of custom vision is that really all you've got to do, the hardest part of that is actually going off and grabbing the images and then uploading those images into custom vision and labeling them. So you just get a batch of oranges or photos of oranges and you upload them. You say, these are oranges, or these are apples, or these are bananas. Now, the trick when you're building these models is not to use images that look too similar. So it's really tempting, for example, just to have an orange and just have an orange at different angles and things like that. It really only works really well when you get, hey, look, this is an orange on a supermarket shelf. This is an orange in my hand. This is an orange in the fridge. This is a bowl of oranges, etc. So the idea is you got to get a lot of variety of the photos, and then you find that the models work really well. And then what happens with these models is that you get back probabilities. So the model will come back and say, hey, look, in this case, you can see I'm 99.99.9%. Whoop, I think someone needs to go on to mute. And you'll see that the models come back and said, hey, look, I'm 99% sure this is an orange, and 3%, 3.1% possibility that it's a red apple. So that's kind of the idea behind it. And then the other service that I was using is Azure Speech Services. And what it was doing for me, so basically I could do text translation. So for example, I could have done English to Hindi, for example, and then I could have got the system to go off and do text to speech, and then actually speak to you in Hindi or Mandarin or whatever you want to go and do. So there's about 70 to 80 languages that we support in that kind of order. Now, what I did and the way this works is that what I do is I send a bit of text up to Azure. Then Azure says, hey, it creates me an audio file, basically an audio byte stream, which I download and I cache it. So I write it to disk on the Raspberry Pi. And that means the next time I see, hey, you've scanned an apple, I don't have to go all the way back up to Azure to go and grab that. So you can do quite a lot of optimizations like that and have it work pretty well offline as well, kind of once you've kind of got it all going. Yeah, just keep an eye on the chat as well. So hopefully that kind of makes sense. So the beauty of it, it's remarkably easy to actually go and build. So what I'm going to do is just kind of give you a bit of a demo of how some of this hangs together. And the first part of my demo is I'm going to go over to, so I've already signed in to Custom Vision AI. So if you just go hunt on the web for Custom Vision AI, and you can go and sign up on the system. Now you can see what you can see in here is I've got a whole lot of images, and on the side you'll see that I've got various kind of categories or labels. So if I go and click on bananas, for example, on here, you'll see that I've got 58 images of bananas. And just coming back to that point before, is that it's good to have kind of variety of different images. Now, by the way, the examples that I'm using here, I've just done fruit. There are lots and lots of examples where I see this being used for agriculture. I've seen it being used in process and manufacturing, where they've been looking for faults and packaging, for example. So they've basically scanned a whole lot of images of a package which is correctly packaged, and some that are not. And then they've just trained the model on that. And the other one I've seen is oil pipelines. The whole idea is you fly a drone down a pipeline, looking for issues. And the other one that I've seen, excuse me, is for livestock. So this is, I'm just doing fruit because it's easy and we all generally have pretty ready access to fruit. And the demo travels well. So you can see I've got bananas, I've got green apples and things like that. Now, actually, you'll see in this example here, what I did is I tried to cheat and I got a data set of Gaggle, which is called Fruit 360. And I thought, hey, great, I've got a whole data set here of pre-canned images I can just upload into my model and it'll all be good. But I found it just did not work very well. I think basically what happened is the model was overfitted. So that's the general what happens there. So you just got to be careful about that. You can also, in this, I've been using this model for a while, and you can say, hey, look, these are other images, and I could go and, I think if I just go click on that, and I could go and tag this image. I think that's the way it works. And actually, I don't think I have an avocado section. So let me go and pick one that I do. There's this banana. And I could go and tag this image here as a banana and just save that. And that would add it to the banana data set for the banana labels. So the really cool thing about this is that you don't have to be like a data scientist to be able to kind of get on top of this. So it's pretty neat. So going back to my trained images, yeah. So just kind of moving through a bit of the UI for a moment. I'm going to jump back to the screen in a moment. But you can see in here, we've got precision recall and, oh, actually, I can't remember what AP stands for. I'm sorry. Uh, it's something to do with performance, wasn't it? Yeah, and you can also see, oops, I think someone's on next door on mute. Let me just see if I can mute. Okay, someone's muted it. Awesome. Okay, so you can see in here, and you can see that, for example, it's telling me that for purple grapes, I actually don't really have enough images. You should really target around about 50 images as a minimum per label. If I just come over to predictions, you can see that these have been various things I've done before. If I just hover over these, you can see, hey, look, purple grapes have typically hit 99% on this trained model. And then when I've uploaded all these models, these images, I should say, and labeled them, I can then go and do a train. And you can do a quick train. So a quick train is free and it's actually pretty decent. I just generally just do a quick train. Or you can do an advanced training. Now, do be aware that advanced training does cost. I don't think it's particularly expensive, but you just want to be aware that there is a cost associated with that. And then once I've trained it, I can go and do a quick test. And in this case here, I'm just going to browse some local files and I've just already put some images up here. So I've got an image of an orange. So I'm just going to upload that and you'll see that what that's done is it's it's uploaded that image into the model. The inference has happened and it's come back and it said, I'm 100% sure it's an orange. And not too many surprises. If I go and grab a couple of others, a banana, it'll come back and say it's banana. And those of you with keen eye will notice that I've got a hand in there. And I just had some hands in there. And the reason I had hands in there is because when I was training the model, when I was putting my hand under the camera to take take a fruit out and put it there and back again, what would happen, of course, is that my hand was shaped a little bit like a banana. So the model would come back thinking my hand was a banana. So what I did is I just basically trained the model with pictures of hands, some of my own and some of them I just found on the internet. And then in my application, if I saw a hand, then I just knew to ignore it. So that's kind of why I've got a picture of hand in there. So hopefully that makes sense. Yeah. And then the next part over here, what I'm going to do is just go back to performance. So once I've trained my model and kind of uploaded all the images, what I can do is I can export that model. And I can export it to a number of places. So I can export it out to Core ML. So if I'm going to build an iPhone application, for example, so I can export this model and if I could go, I still need to build the iPhone application, but I've got the model that I can then include as part of my application to go and ship an iPhone application or an iPad application which does image recognition. The same thing applies to TensorFlow for Onyx as well. And there is something called the Visual AI Dev Kit, which I'm actually not going to do here, which is not set up here. And the last one, which is the one I actually use, is to be able to export this model out to a Docker file. And what I can do is I can choose really where I want to export this. So I can export it out as a Linux container, as a Windows container, and as a Raspberry Pi container, or basically the Docker file for it. Now, what I'm going to do is I'm just going to drop that down. In this case, I'm just going to do this on my desktop. And literally, I would just take that, and you can see it says downloading onto my desktop as a zip file. Now, rather than you watching me unzip a file and move things around, I've already kind of pre-canned one that I've done. It is exactly the same. I just did it before. And when you get this exported Docker file out of this exported model for Docker file out of Custom Vision AI, what it does is it gives you pretty much the whole template for the application. So you can see in here what it's done is it's giving me the Docker file for the solution. What it's going to do is it's going to be exposed out on port 80. And if you played around with Docker, you kind of recognize this. It's doing like a pip install, and it's doing NumPy, TensorFlow, and Flask and Pillow for doing some bit of image manipulation. So you kind of get all that. You get a README file, so it tells you kind of how to go and build it, which is pretty cool. And then the other thing about it, of course, you get the app. So what you get is a Python app. And to be more specific about it, what it generates for you, the template that gives you is a Python Flask application. So it's basically giving you a Flask application, which is exposing a REST endpoint. And you can see here, these are the endpoints. So it's going to, the URL that's going to respond to, you could send it to port 80/image, and then you could do a post, and then you could bundle that data for that image on the post, and it would hit port 80 inside that container, and then it would run on the model. So that's kind of the overall framework for the application. And then there is another Python file that you get as part of the template called predict.py. And in here, you'll see it's just basically, it's a TensorFlow application. So it's pretty cool. Now, actually, it's not the world's most optimal one. Actually, no, that may not be true. This one might have been fixed. So actually, this one's probably okay. But it can be useful if you're trying to kind of get your head around TensorFlow. This can be quite a cool way of just understanding how TensorFlow works as well. So definitely do check that out for that. And then there's obviously things like requirements that go on there and stuff like that. Now, was there anything else I was going to show on that? But so hopefully that made sense. So I just went into Custom Vision, I trained up my model, uploaded my images, trained it, and then I downloaded it. And these, as you can see, these are other labels that you saw up in Custom Vision. So I popped back up to Custom Vision, across over to trained images. And if you look down the left-hand side there, you see I've got banana, green apple, blah, blah, blah. And you'll see that these are the same labels that have been exported. And you can see that there goes my TensorFlow, or there goes my TensorFlow model. So once I've done that, the next thing I want to go and do is I want to go and build the model. So inside Visual, so I'm using Visual Studio Code, by the way. So fingers crossed, most of you are familiar with that. And I've loaded up a couple of extensions. The main extension that I've loaded up is the Docker extension. So over my Docker file there, I'm just going to go and build this image. Now, this will go through pretty quick. So you'll see at the top of my screen, I've got Custom Vision Fruit and later. So that's going to be the name of the image that is going to be built. And Docker will dutifully go off there and build that. And as I said, I've already built this before. So it built super quick because it's all cached. Otherwise, it probably took about 5 to 10 minutes, depending on your internet speed to go and build it. So now I've built my image. What I'm going to do is go across to the Docker tab, And you can see in here, I've got the images that are on my machine, my local, the local set of Docker images that I've got currently built on my local machine. And you can see this is the one. Now, the reason it says 5 hours ago is because I built it 5 hours ago. And my last build was all cached. So what I can do is I can run that image up now. So I've just started up that. Well, that didn't look good. Port is already allocated. I've got a funny feeling. Sorry, I'm just going to do a Docker stop. Sorry about that. I could just use the one that's already there. But anyway, I'll just stop that. In fact, I could have stopped it up on the UI here as well. Well, hey, okay, it stopped. So if I go here and run interactive, and you'll see that that started up that Docker image so that the container is now running, and you can see that it's listening on port 80. So what I'm going to do now is I'm just going to minimize or change that screen to a window, and I'm just going to open up this folder inside the Linux shell. So what I've got on my machine here is I've also got WSL, so WSL2. And the reason being I've got that on here is I want to use some Linux commands. So I wanted to use curl, and it was a super easy way of doing this. So just so you know, what I've got in here is I've got, this is just the same. If I just jump back to that folder, you can see in that folder here, I've got a banana. Okay, so that's where all this is just coming from. And the same thing, I've got a bunch of grapes in here. So if I just jump back to that WSL container, you can see this is exactly the same folder. And then what I'm going to do is curl this. And what I'm going to send the image to the model that's running inside the Docker container. And we will fire that up. And what it did there, and if you're wondering how this kind of worked reasonably well as well, shows quite nice. I've piped this through a JSON processor. So it does basically it does pretty print for JSON. And what was the one I sent? I sent through a hand. And you can see down here that the probability of this image being a hand is pretty much it's pretty much 100%. And as I mentioned before, often my hand would be confused with a banana. So you can see that it's kind of showing some hints of being a banana in there too as well. And if I go over here and push orange, so you can see down the bottom of the screen, if I go and push orange through that, it's come back and it said, I'm 100%, that image that you've just sent through is an orange. So that was pretty straightforward. So the next thing I want to do is, in fact, just jump back to the slides. So hopefully you kind of got a bit of a sense of how that works. There's some pretty decent extensions inside Visual Studio Code for Docker, and you can see you can kind of got good experience here on the UI. Now, one of my other favorite projects is a Kubernetes cluster that I built. So if you go and check out my GitHub, you'll see that there I've got full instructions on how to go and build a Kubernetes cluster. And on there, I'm running various things. And I'm actually, so again, if you take a screenshot of that, you'll be able to kind of figure that. Now, this cluster is actually built out of 2 Raspberry Pi 4s, and I think it's a Raspberry Pi 3B on the top, just being as a Kubernetes master. It's an awesome way to learn Kubernetes, by the way. Now, you don't have to have Raspberry Pi 4s as nodes in the Kubernetes clusters. I've done this with Raspberry Pi 2s and 3s. It works super well. Obviously, it goes a bit faster if it's running on a Raspberry Pi 4. So just to bring this up again, so I would just, now what I've done, I'll just double check that I've actually started this all correctly. So if you played around with Kubernetes, I basically started up a proxy to the Raspberry Pi that's sitting on my home network. And I'll just create a new tab, and I'll just sign into my Raspberry Pi Kubernetes cluster. And you can see that this is the cluster here. And I've got a couple of Azure Functions sitting on this thing as well. So if you've played around with Azure Functions, you'll appreciate they're highly portable. So I'm actually running Azure Functions on the Raspberry Pi as well for that LED controller. And it's running Nginx web server. But on here as well, I've also got the image classifier. Now, this is exactly the same thing that I showed you. So I downloaded this model. I downloaded this time for Raspberry Pi, and I built the image for Raspberry Pi, and then I wrapped it up in a bit of Kubernetes. I defined a YAML for a deployment, and I deployed it onto the Raspberry Pi. And you can obviously do things like look at the scalability. So for example, I can come over here and I can say, for no particular reason, I'll just say, hey, look, I'm going to scale this Kubernetes cluster up with this container. This is basically Kubernetes is an orchestrator for Docker containers. Is the easiest way to think about that. Oh, that doesn't look good. Hopefully that'll come back in a moment. Yeah, cool. So what we've got now is I've got 4 instances of that image recognition running on the Kubernetes cluster on a Raspberry Pi. And it's amazing what you can throw this. I would probably I probably have something in the order of 20 clients hitting this. And I get typically around about 800 milliseconds to maybe 1,000 milliseconds up to about a second hitting this Raspberry Pi. So hitting this cluster, because obviously the workload's being distributed across all the cores and the multiple devices. So what I'm going to do now is just go back to my WSL instance, and whoops, that's the wrong one, sorry. What did I do? I lost myself here. I think I might have closed it by accident. I'm just going to jump back to open this up in the Linux shell. And this was the last one I did. Oh, no, it's the second last one. So we'll go to oranges. And the only difference between this now and before is that this lives on a different address. And from memory, hopefully my memory is good, 202. And so what that did is it now went across my home network, sent that image to my Raspberry Pi, and obviously the Raspberry Pi, one of those instances, or those 4 instances that I set up on my Raspberry Pi, obviously responded to that. And I said the beauty of running that in a Kubernetes cluster, clearly you could also run this Kubernetes in the cloud or on your laptop or whatever. I just kind of like playing with Raspberry Pis. So, and you can see in here, so I put in an orange, didn't I? And if I look over here, there goes the orange, and it's come back basically saying it's 99.99% sure that it is an orange. So hopefully, anyway, it kind of gives you, so it's pretty cool with what you can do. As you can see that all this has been done in Python. I didn't have to get too involved in actually doing too much of the work around classification. Really just a matter of uploading the images, and then, hey, I've got a pretty neat system that's running on my Raspberry Pi or on my desktop and running in Docker or up in the cloud or wherever you want to put these. So hopefully that kind of makes sense, and it's pretty neat. Okay, cool. Right, so I'm just going to jump back to my slides now. Okay, so the next thing I'm going to talk about is how do I get that data up into the cloud? So what I've actually got, so I'm just talk a bit about in the next slide, in fact, how this actually works. So this section here is really on cloud integration. So what's actually happening, which I didn't kind of go into in a lot of detail for that first demo, is every time I got a positive, I set a threshold. So I said, hey, look, I'm really only interested in things which have a greater than 80% chance or 80% probability of being correct. If it was less than 80%, then I ignored it as kind of like a false reading. And then every time I got a positive reading or above a certain percentage threshold, what I did is I sent a message to Azure IoT Hub. Now, again, you can do this for free. So you can set up an Azure IoT Hub, and you can do it for 8,000 messages per day for free. So this what the solution's doing is it's sending a message. This is basically an IoT solution. So it's sending the a JSON string up to Azure IoT Hub. And then what I've got is I've got an Azure function, and it's listening on events or listening on messages landing in IoT Hub. So now the way this works is that you have the kind of guess like the client side of IoT Hub, which is where all devices are, which all connect into IoT Hub and it can be streaming messages up to IoT Hub. And then you have the service side. Now the service side of IoT Hub looks like an event hub. So what I've done is I've built a Python function which listens on Event Hub. And I've obviously given it the connection string for the Event Hub, which has been presented to me from Azure IoT Hub. So what happens is that message comes in from my Raspberry Pi. I get a positive, hey, look, this, I've just scanned an apple. And then I send that message up to IoT Hub. And then I have the Azure function saying, oh, there's a new message. And then that starts running. And then it gets the string, it gets typically a collection of these messages, and then it processes them. And then what I'm doing is I'm writing each one of those, each time I get a count for a green apple or an orange or whatever, I write that into storage. Now, I'm actually using Cosmos DB, but you could also do this if you're not worrying too much about scalability. You could actually do this just with storage, table storage. Super cheap to be able to do if you just want to kind of play around with some ideas. Obviously, you want to kind of do this in a bit more in Angular, more production level. Then you would go and you probably use something like Cosmos DB or SQL Server or something like that. But you can see over here, I've got a table, and all I've done is I've written that data into that table. I'll talk a bit more about that. So if you're not familiar with Azure Functions, and I suspect if you're in the Microsoft ecosystem, you've done stuff around Azure, you probably have used them already. The beauty of them is that they're super cheap to run. You don't have to worry about infrastructure or the networking, the operating system, or patching anything, or patching the frameworks, anything like that. That's all done for you. All you've got to do is build your application. Say, hey, look, this is my Python application. This is my Python function, or I've written one in Java, or Node, or C Sharp. I think those are the main languages that we support. Yeah, and so you can write them in multiple languages, and you can run them inside Azure. You can run in the order of, I think it's in the order of about 2 million of these per month for free if you're using a consumption plan. Now, there is a bit of a nuance in that. It also depends on how much memory you're using and how many seconds you have that loaded in memory. But if it's a small function, it won't be using much memory. And the idea with functions is that they should run super quick. They should just, message comes in, bang, start up the function, do the processing, shuts down, move on. So that's kind of how that works. So the beauty of functions is you don't have to worry about all the infrastructure. The other beauty about them is that they will just scale on demand. Now, it depends on which plan you're on, depending on how this will work. But you can also set a limit. So you can say, hey, look, I will tolerate 10 instances. I'm not prepared to pay more than 10 instances of this function to be running. And obviously, it's not going to cost much, but you would set some kind of sensible limit to say, look, I will let this scale up to you depending on demand. And then you might cap it. And the other thing about it, which I've kind of alluded to, is that they're super cheap to run. So they are really pretty useful. And the other thing I mentioned before, just to kind of reiterate this, is that um, functions, there's a function runtime, and that is all open source. So you can choose to run your functions up on the Azure data center. You could run them on your workplace server, kind of on-premise server. You could run them at home on your whatever it is, or you could run them on your Raspberry Pi for that matter, which is what I was doing when I showed you that Kubernetes cluster. So super portable and a great model for just kind of on-demand compute. And you really just pay, and the beauty of it, you just pay for what you use. And this is an example here of an Azure Python function. It's just a bit of Python. As I said, you can do them in Java, you can do them in Node, you can do them in C Sharp, and you can go and build them in Python. Okay, so now I've got the data up in the data store. What I'm going to do now is just show you kind of a little bit of, it's basically a trick. We're just going to give you some sense what you can do with some of the developer tools to help with Jupyter Notebooks. Now, if you've done any Jupyter Notebooks, and if you're like me, if you got stuck on something and you kind of like, oh, an object, I couldn't find an object not found, whatever it is, you would invariably put a print statement in your Jupyter notebook. And I feel sure that everybody is guilty of doing that. We kind of get stuck on something and say, oh, I don't know the value of that object. So you can put a print in there. And then after a while, you get your Jupyter code, your Python code is kind of sprinkled with all these print statements, trying to figure out what's actually going wrong. Um, print is the Python debugger, I know, and it shouldn't be. So what I'm going to do is just show you kind of some tricks that you can do. So we just jump back to my desktop again and just kind of minimize this down, minimize that down as well. In fact, I'm just going to close that because otherwise I run the risk of confusing myself. Okay, so first thing I'm going to do is I've got the Azure Storage Explorer. So you remember I said that ultimately this data ended up in storage and I put it in a Cosmos DB. And honestly, I've got so little data on there, it doesn't have to be in Cosmos DB. And frankly, the API is the same for table storage as it is for Cosmos DB. So I moved it across from storage to Cosmos because I wanted to learn about Cosmos DB, which is really around providing really high performance and highly distributed data storage, which obviously in this example I didn't technically need. Um, Best debugger I've ever known, humanity print line. Hopefully we can do better than that. Right, so I'm going to go to the browser, and what I've got over here is, of course, now I can't see behind. Right, just going to move that around. And I've got Jupyter Notebooks running on my desktop, and I'm literally just running, so I'm just running Jupyter on my desktop. And what I've got in here is I've got a Jupyter Notebook, which I'm going to run, and it's got a bug in it. And I'm just going to step through here and we're just going to load up various components. So you can see in here, I'm loading up the Cosmos. Hopefully this is, I guess the advantage of watching this on your screen is a bit smaller, you get a bit closer to your screen. But you can see I've got Cosmos DB and I'm also using matplotlib. And then I'm going to run a query and that's going to return back a JSON object, JSON, basically a collection of JSON strings with the data that's come off from Cosmos DB. And you can see in here, I've done a filter on this. So you can see I've got a petition equals to register one. And if I just jump back over to storage, you'll see that I've got a petition key over here called register one. And I just said, bring me back everything. Now, clearly you want to be a little bit more careful about how much data you want to bring back. But it was super simple because I didn't have a lot of data. And then I'm just going to run through that and run this next cell. And voila, I get the message from hell that we have all no doubt seen if we've done anything in Python and Jupyter notebooks. And if you're anything like me, you look at this and you think, I've got no idea what's going on, and I don't really understand what this message is. And I feel sure I'm not the only one to have done that. So what have I normally done in the past? I've normally started just breaking the problem down and putting print statements in there. So I'm going to show you that there is a better way. So what I'm going to do here is I'm just going to come in here and I'm going to download this notebook. Now I've actually got a funny feeling I've already got one in my downloads folder already. So I go across to my downloads folder and I'm just going to double click on that. And that's going to open it up in Visual Studio Code. And what it would do is it would load up the native experience that we've now got inside Visual Studio. So Visual Studio Code. So I can come in here and I could start putting in some Python code and you get all the beauty of things like IntelliSense. Oop, I think someone's not on mute. He probably needs to be on mute. Sounds like someone's driving somewhere. Hopefully
Dave, you're muted.
Hey, cool. So I think someone might have muted me by accident. So hopefully, I don't think I got too far. So what happened then is I was just stepping through this experience inside Visual Studio Code. Step through that, goes and do that, and then go and run this problematic cell. And look, I get this message which I don't really understand. So what I can do now is that you can see in this thing here, I can convert this into a Python script. And I'm just going to save this, and I'll just save it as debug.python. And I'll run the first cell. Now, this is not always the easiest thing to kind of work through, but now what I've got, I've got this is basically the debug experience now for Jupyter Notebooks. So you can see through here that what's happened is the first cell actually started up an instance of Jupyter Notebooks on my machine, or for this debugging session. And then I'm going to run the next cell, and then run the next cell, and then run the cell over that, which is going to do a couple of imports. And then I'm going to run this cell here, which you remember, this cell is going to talk up to Azure Cosmos DB. And that's going to grab that JSON data that I showed you before. And then I now know, and before I'm not going to bother running it because we all know it's broken already. I'm going to put a breakpoint in this. I'm going to click on debug cell. And then now what I can do is I can step through this Jupyter notebook. And so I'm just going to step through here. So basically what this bit of code's doing is I'm just taking that collection of JSON that I had, and I'm just iterating through each bit of JSON, that JSON and that JSON string. Now, there's probably a better way of doing this, but this certainly works for the purpose of this demo. And I'm just going to go through here. And then what I'm going to do is I'm going to hover over Y. And you can see that I've got three values in there. I've got 42, 56, 68. And then I hover over X, and you see that I've got the dreaded none, which basically means it's null, it's none. There's nothing in that list. And then and this actually happened to me in real because something changed. And what happened, and this always happens, is that your bit of Jupyter Notebook worked perfectly one day, and then something's changed. And this is what happened with me. Something changed. And so you can see what in here as I'm looking for an item called tag. And this worked the day before. This was all perfect. And if I go back, look through my JSON string over here, and I look through this, which is not necessarily the easiest, and you can see one there, and you can see over there. And what had happened is that basically the schema had changed. So instead of being called tag name, it got changed. So instead of being called tag, it was changed to tag name. And I didn't know about that until I came to run my Jupyter notebook. And so what I'm going to do now is run that. So I just stop that because we know this is going to fail. And I'm just going to rerun the cell again. And now we'll step through it. And I'll just do this a few times, and I'll hover over X again. And you'll see now I've got the variables coming through. So you can remember, these are just the labels. So this is green apple, red apple, orange. This was the original labels that I had in Custom Vision that found its all the way down, found its way from my Raspberry Pi over to IoT Hub, from the Azure function, and then it got written into Cosmos DB. And now I'm just kind of doing the analysis of this. And then I'm just going to run this, and hey, look, it works. And we just scroll down through here, and it worked. I know it's a bit confusing because that's just the previous execution. And you can say, hey, look, I've got my matplotlib, my map, is it my matplotlib? If I just go and double click on that, hey, look, I can go in there and I can go and dig into the data. Okay, this chart's not that exciting, but you kind of get the general gist of it. And you can also go and save it, and you can go off and save it as a PDF or a PNG. So let's go and just save it as a, and I'm just going to call it chart. And we'll save that. And then if I come back over into my file system, into my downloads, you'll see I've got chart.png. And there goes my chart. In fact, it's loaded up in paint.net, but anyway, you can see that's sitting in there. So pretty neat with what you can do. So I've got to tell you, it's as tempting it is to go and just try and debug a problem with print statements. The Jupyter Notebook and the Python debugging is actually really pretty cool, to just get through that pain. There's also, uh, yeah, that doesn't quite make sense where I was going in that. So hopefully that gave you an idea of what you can do. Where I was going to say, I'll just close it over here. You can also, now I'll just go and fix this over here because I know that this will work now, and I'll just go and run that cell. You can also go and do data exploring, and you can see all the variables and things like that. So this is inside my Jupyter Notebook, and you can see the current value of all your variables. So it's pretty neat. Now, at the moment, you probably noticed that I went out of the Jupyter Notebook experience into kind of more scripted Python to do the debugging. So that kind of process will improve over a period of time as well. Okay, so I think we're pretty much there. So hopefully that kind of made sense. So I had stuff in storage, I use Jupyter Notebooks, and I use Visual Studio Code, and I used the Python extension, by the way, to do that Jupyter Notebooks. And that was a demo, so I've been through that. And yeah, so that's kind of the demo. And yeah, so a question I often get asked, I'm just kind of included in this. So I kind of just tend to try and end with a bit of this. People often ask me kind of how do I go and learn stuff? And I think the best bit of advice that I always kind of give, and I tend to give out as well, is find a fun project. So I love IoT. I love Raspberry Pis. I like hacking on Linux. I love hacking on Windows and Python and blah, 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 all that kind of stuff. The cool thing about finding a project is it forces you to think through all the kind of aspects of your project. And because invariably what will happen is you'll start, okay, I can read something on that Raspberry Pi. Now I can read that, I don't know, that sensor. Now I want to be able to send that sensor, that data to the internet. Now I have to worry about security. Now I have to worry about connecting up to Azure IoT Hub, for example. And it just forces you to think about things through end to end. And
But how to
so,
define this code in a Raspberry Pi?
whoops, sorry. Hey, so anyway, just before that question, um,
Can you
sorry, go
can
for
you
it.
can you show the deployment to Raspberry Pi?
Can I, what, sorry?
Can you show the deployment how to deploy this image classification to Raspberry Pi?
Ah, okay. So what I could do is it's probably a bit much in the scope of this session here, but if I go to my GitHub, and so this is my GitHub here. So I'm pretty easy to remember. My name's Dave Glover, and I tend to go by the nickname Glovebox or Gloveboxes. So if you go and look on Hackster or Dev.to or GitHub, go hunt for Gloveboxes. And the one in here is, I've just searched for image, and you can see that there's this thing here called creating an image recognition solution with Azure IoT and cognitive services. And in here, there is a complete walkthrough. You can see, in fact, I actually had this running super well on a Raspberry 3A, which is actually, it was a gorgeous little device, and it ran really, really well. And I've got really all the steps. So this is an architecture of the solution, and there's a description there of IoT Edge, and there's how this all works. There goes the image of the Raspberry Pi. You can see there goes how to export the model, and you'll see that I kind of go into how I actually built it and deployed it. So there's a hang of a lot of information that's sitting up on my GitHub. So the way that I had this working on my Raspberry Pi, just to be a bit clearer about this as well, I actually had two Docker containers. So I had one Docker container whose sole responsibility, I actually had two responsibilities. Its main responsibility was to run the camera. So what was happening is the camera's just going on around a loop, and just the camera's just saying, grab me a photo, and then I get that frame, and then the code then goes and sends that frame to the REST API in this other Docker container, which is running that custom vision model I exported. That then replies back to the other container, And then that container says, okay, that was above a certain threshold. I'm then going to send that message on to Azure IoT. So just to be clear, when you look at this and you think, hang about, how come he's got two containers? I've got two containers because I've got one which is kind of like the controller, which is just what running the camera. It's also managing the speech, by the way. So it'll also make a link out to Azure speech services. It goes and grabs, sends up the string that I want to convert back into language, English in this case. And then I get back a stream of bytes, and then I save that into just onto the SD card on the Raspberry Pi. So the next time I don't have to go and grab the same stuff again. So it just makes it a lot faster, faster startup and things like that. So you'll find all the write-up for there. So does that answer your question? Hopefully.
Yes, yes.
Okay, cool. Thanks. Um, hey, now, so that's pretty much the end of the session. Now, are there any questions on here? So, I'm actually super happy for you to either write them down or just go take the mic off mute.
Could you like share the resources QR code once again?
Yeah, sure. Yeah, that's sitting up there. Now I said I was also going to share, which I know is not in this link. Sorry. Hopefully I'll just do this off screen. Oh, sorry, I moved the wrong window. Let me just move that back again. And I'll try. Now that Kubernetes cluster again is up on my GitHub. So go to glove boxes and just type in kube. And there goes the complete write-up for the Kubernetes cluster. And I said, you don't have to run this on Raspberry Pi version 4. So if you're like me, you've probably, well, I certainly have been buying Raspberry Pis kind of for a long time. So I end up with a collection of 2s and 3s, and they run super well. And I'd also thoroughly recommend this book here, which is called Kubernetes Up and Running. I ended up building the cluster first, and then I found the book second. My recommendation is actually go and read the book first, and then build the cluster. But you can see there's a whole layout there of the networking and how it all works. Recommended parts and bits and pieces there I got off eBay and off Amazon and things like that. So yeah, so that's how to go and build the cluster. So USB would be better. I'm not quite sure what that question was going. So are there any other questions? Now here, would you recommend using a USB camera like the one you used? Okay, so the question here, right, good point. So would you recommend using a USB camera like the one you used or the Pi camera? Now, the reason I used a USB camera was I originally built this from a Linux desktop. It was just easier like that. So that's a dirty little secret that I didn't tell you. When I originally wrote some of the Python code to control the camera, and I did a whole lot of optimization work. And basically, I inherited this project from somebody else, and then I did a whole lot of optimization. I used a USB camera because I actually developed a lot of it from my Linux desktop, and I did that. And then, of course, it was easy for me to go and port that across to Raspberry Pi because it was Linux as well. And that's why I used the USB camera on the Raspberry Pi. And I went and used OpenCV. So that's the story behind why I used a USB camera, is because I built it on my desktop. I had Visual Studio Code on my desktop. It was much easier for me to debug, all those kinds of things. And obviously I couldn't use the Pi camera. So hopefully that was a good, hopefully that was the reason here. Do you always need to train the models? Aren't there pre-trained models available to identify objects? The answer, there is. So the question there are pre-trained models. Now those models, I don't think you can export down to your local machine. Now, the way that this actually works is that this actually uses, oh gosh, I hope I get this right, transfer learning. Pretty sure this is using transfer learning. So what we've done is that we've built up a whole lot of models, so that when I come along and just go and add in the fruit, for example, here, it's using all the models all the training that we've pre-done, and we're just basically adding a top layer to that. It just means you don't have to use so many items to go and train that model. Can you share the QA code? Yeah, sorry. Where's my PowerPoint? If I could figure out how to get this to be half my screen, and then I could look at the questions as well. Can you please recommend a small project to try and learn IoT and AI? Okay, look, if I'm brutally honest, I really like the one that I did. Now, what I would do is I would go up to hackster.io. If you've not been up there, there's some really neat projects. So I'll just jump over here. Sorry, you probably want to look at that QR code. Hackster.io. And this is one of my favorite sites for hacking on. And then go hunting for Raspberry Pi. And I don't know, let's go for, well, I'm not sure how the search will work like that, but let's see what happens. And you will find, now there's a really neat one that was written by a colleague of mine. And what this one did, yeah, this is the one. Now, what she did is that she actually plugged in a Coral board from Google, and she trained a model up on Azure Sphere. So not Azure Sphere, that was last week's talk, using Azure machine learning services. She exported that out and then actually ran the model on there. So if I was looking around, go check out Hackster. It's full of really awesome projects, and you can go click on here and you can basically filter things. So if I go looking over here for Raspberry Pi, for example, you will find a stack of projects from everywhere in the world, where people have built some really neat projects. I quite like publishing on here as well. So that's kind of one of the places I like to go. If I develop a model using TensorFlow, I need to develop a model on Raspberry Pi. So no, I don't think there is any need to change the model format to that question. No. So the question was, what is the algorithm? Look, if you go searching for it, I did find it. And I'm sorry, I can't find it off the top of my head. I don't remember off the top of my head, but I did go hunting around for this. I'm not sure you're going to get the absolute answer to it, but you will find information out there about it. Yeah, so Mahid, maybe. So I probably mispronounced your name terribly. It is an awesome site. Name of that website. So the name of the website I went to was Hexter.io. So just put that in there. Yeah, so Hexter. Yep, cool. And are there any other questions on here? If I've missed your question, could you please share the resources QA? You were using Jupyter on your local machine. So the question was I using Jupyter on my local machine? Look, I was, just for simplicity. But yes, I could connect this Jupyter notebook to a remote Jupyter server, and very likely I would. I did it for simplicity, by the way, just because I knew everything was kind of there and it was going to work. Okay, so I talked about the cameras, doing it. Yeah. What are we doing with the NB here? So I'm not sure what that means. Okay, so I'm even making projects. So someone here is making a project. Oh, cool. Someone's doing an AI project for self-driving cars. Yeah, there's some really interesting models floating around, and you'll find them on hackster.io as well for self-driving cars. People built self-driving robots and things like that. Yeah, and the slides, I will put them into the chat here as well. Okay, so I think that's pretty much time. So I think I'm probably getting kicked off. So hope you enjoyed that. And hey, thanks so much for checking out, and stay safe, everybody. And I saw in the news today that there's been storms in India as well. So hopefully your family is safe. So. Thanks so much.
Thank you so much, Dave. Thank you so much, and thank you very much, everyone. I guess like a lot of your questions has been answered, and if you still have questions, feel free to ask Dave on his Twitter. Okay, like feel free, and this video recording will again be there on YouTube of Reactor Global, so you can check that. We'll be sharing it on Twitter as well. So yeah, like that's about it, and I guess wish you all a good weekend. Wish you a very happy weekend, Dave, and we'll see
Thank
you
you.
on the next one, like
Hi,
next week.
please include the
Alrighty.
QA. Please include the QA portion also in the recording.
Yeah, definitely. I'll do that, Abhi. Thank you so much. Thanks for the suggestion, guys. And please drop down if there is anything. You can just directly let me know. You can just message me. My name is Paras. You can just message me something specific if you have, and I'll try to help that out also.
Sure.
Perfect.
Okay, very nice section.
How do we get to know if there are more events like this?
Is it? Just a second. I'll help it. I'll help everyone with that. I guess you can just go to. I'm sharing. Here is the link. You just pick that up like next week. Dave, if you want to take off, it's fine. I'll just make sure everyone
Okay.
is here. Thank you
Alrighty.
so
Have a
much.
great weekend, everyone.
Thank you so much.
It's a pleasure. Have a great weekend, everyone. Take care.
You too.
Cheers. Bye.